Competitive sport is divided on the basis of sex due to differences in male and female athletic ability. Such sex differences begin in the womb and develop further in response to hormones during puberty. As both sexes mature, males exhibit physical performance advantages over females. This is why we separate sports by sex. However, this separation has excluded transgender women from female sports. To solve this, the International Olympic Committee determined criteria by which a transgender woman could be eligible to compete in the female category. This criteria required testosterone levels to be suppressed to 10 nanomoles per liter for at least 12 months before competition. Despite the regulation, a major question remained unanswered. Does this testosterone suppression remove the male performance advantage? We're going to answer that by exploring 3 questions. 1. What are the biological differences between males and females, and how do they relate to sports performance? 2. How big is the sports performance gap between males and females? 3. How does testosterone suppression affect the answer to question 1, and thus question 2? We'll start with question 1. What are the biological differences between males and females? Compared to untrained and moderately trained females, equivalent males exhibit 45% more lean body mass and 30% less fat. In muscle mass, males exhibit 33% more lower body and 40% more upper body. In muscle strength, 57% more grip strength, and 54% more knee extension peak torque. In anthropometry and bone geometry, 9.4% greater femur length, 12% greater humerus length, and 14.6% more radius length. In tendon properties, 83% more force and 41% more stiffness. In terms of the amount of oxygen one can utilize during intense exercise, known as VO2 max, males are able to utilize between 25 and 50% more oxygen. In respiratory function, males exhibit 48% greater pulmonary ventilation, allowing more air into and out of the lungs. Finally, in cardiovascular function, males exhibit up to 43% greater volume of blood ejected from each ventricle, and an 11% higher hemoglobin concentration, allowing for more efficient oxygenation of muscles. In all, compared to females, males have higher lean mass, less fat, more muscle mass, higher strength, longer bones, a narrower pelvis, stronger tendons, higher lung capacity, and higher cardiovascular output. This means that males are better at sports. But how much better? This brings us to question 2. How big is the sports performance gap between males and females? If we set the female performance level at 100% and compare to males, we can see that males have a competitive advantage, starting at 10 to 13% in activities like rowing, swimming, and track running, 16 to 22% in field jumping, tennis serve, golf driver speed, handball shot, and pole vaulting, 29 to 34% in cricket, volleyball serve, golf long drive, and weightlifting, and a more than 50% advantage in baseball pitch and field hockey. The more upper body strength is required in a sport, the larger the male performance advantage is. Take weightlifting, for example. Males lift 30% heavier than females, not in different weight categories, but in the same weight category. This means that even if you equalize male and female body weight, which often serves to make height approximately equal to, the males will be able to lift 30% more. In all, the biological performance advantage for males in competitive sports ranges from 10 to 50%, depending on the sport. Now that we've answered questions 1 and 2, we can evaluate question 3. How does testosterone suppression affect biological differences, and therefore the performance advantages? To answer this, we present 11 long-term studies of muscle and strength changes in adult transgender women undergoing testosterone suppression. Study 1 shows, after 3 years of testosterone being suppressed to female levels, a total muscle area loss of 12%. This was the first study to measure changes in muscle size, and no study since has seen the same amount of change. This loss of 12% is as high as it gets. Remember, at baseline, males have over 30% more muscle than females. A 12% loss isn't enough to equalize this baseline difference, and the authors of this study conclude that while males lose muscle size, they retain significantly more muscle than females. The conclusion can be visualized in this graph. Study 2 shows barely detectable changes after 1 year. Study 3, after 2 years, a loss of 7% muscle strength. Study 4, a loss of 5%. Study 5, a loss of 9%. Study 6, a loss of 2%. Study 7, a loss of 3%. Study 8, a loss of 6%. Study 9, a loss of 4%. Study 10, also a loss of 4%. And finally, Study 11, a total muscle strength loss of 5%. What's left is the math. The male sports performance advantage ranges from 10 to 50%, and testosterone suppression reduces the muscle mass and strength that accounts for a majority of this sports advantage by only 2 to 12%. For a concrete example, consider the strength-based sport of weightlifting. If the original male advantage in weightlifting is 30%, then testosterone suppression reduces this advantage by 10% at the high end and 5 to 7% on the average. This leaves a more than 20% advantage in weightlifting, even after testosterone suppression. As Hilton and Lundberg write, quote, "The data presented here demonstrates that the male physical performance advantage over females, attributed to superior anthropometric and muscle mass strength parameters achieved at puberty, is not removed by the current regimen of testosterone suppression. Rather, it appears that the male performance advantage is largely retained by transgender women, and thus remains substantial." Unquote. From the data presented, we recommend the International Olympic Committee review their policies for eligibility. Quote, "If those policies are purported to promote fairness, inclusion, and safety of biologically female athletes, this review compels sporting organizations to reassess their policies regarding inclusion of transgender women." Unquote. I'm Zach for the Paradox Institute.